Welcome to the final video for forces for AP Physics 1 Cram video. This will be on accelerometers and the definition of systems and how it relates to the Earth. Okay, let's say I've got a train that's accelerating in this direction, and someone placed a little pendulum on top of it, maybe the caboose, and this is the supporting stick here for the pendulum. And there's a very light string attached to a mass right here, this ball here. And as we accelerate this way, the mass swings backwards and opens up an angle here. And we want to know, what is the acceleration of our train? Well, let's take a look. We're going to be looking at the forces acting on the sphere, the ball that swung backwards. So, of course, we have force gravity straight downwards. And we're going to have a tension force in this direction here. And that tension force is going to be broken into force tension X and Y. And I'm drawing them right now. And let's label everything here. So this is going to be force tension in the Y direction. This will be force tension in the X direction. And this, of course, is force gravity. And force tension is our hypotenuse here. I won't draw that so it doesn't get too confusing here. Our angle theta is here, but if you look at our geometry here, that means also angle theta is also right there. Okay? And let's see what we know. Well, force tension Y is what's opposing force gravity downwards, so we know these two are equal to each other. So force tension Y does equal mg, because that's what force gravity is right there. Now, this whole ball, of course, is accelerating with the train together. So what force is causing it to accelerate this way? Well, that's force tension X. It's drawn up here for clarity's sake. Okay, and here's our force tension again. So we have force tension X and force tension Y defined by this angle here. Well, it looks like I have an opposite over an adjacent here, right? So I could say tangent of theta is equal to my opposite, force tension X, over my adjacent, which is then going to be force tension Y, which is actually mg. So notice what I'm substituting there. Force tension Y I would write there, but that's also equal to mg. So now I know that force tension X is going to be equal to mg tangent of theta. Now, assuming that there's no air resistance acting on this ball, or is very little, we can ignore it. What's our net force acting on this object would then be force tension. So force net is equal to force tension X. Okay, well, you can always substitute MA for force tension, and I have this expression for force tension X. Let me write that over here for clarity. So then I have mass times acceleration is equal to mg tangent of theta. And I notice that m's can cross off on both sides. So the acceleration is a very easy equation for an accelerometer. It's g tan theta. And g, of course, being our 9.8 on this planet. But you can do this on any planet. As long as you know the angle and the acceleration of gravity on that planet, you can find the acceleration of the object. Okay, now what about systems here? Well, we have a system here. In this case, we have Snoopy on a doghouse. Okay, we have Woodstock on Snoopy, who's also on a doghouse. So we can define our system in a variety of ways. Okay, let's say we're going to take care of a math system that does include the Earth. Okay, so let's take a look at, first of all, the doghouse. Of course, we do have force gravity going downwards. Okay, and then, of course, force normal going upwards. Okay, so how do we write all this stuff? Okay, so let's do it this way. Again, we're going to be using Newton's third law here. So this is going to be force, okay, of gravity. Okay, now what's actually causing that? Okay, I'm going to do a little subscript here. Okay, this is the force of gravity from the Earth, I'll just say E, that's pulling on the house, H. Okay, so there you go. So we're including the Earth in our system here, of course. The Earth is the one causing the pull on this going downwards, okay? Now what really is our force normal here? Okay, that is going to then be the force, okay, that the Earth or the surface of the Earth is pushing back, okay, on the doghouse. So this is going to be Earth pushing back, okay, on the doghouse. Okay, and we call that force normal then. It's force normal from the Earth, okay, pushing back, okay, on the doghouse. Okay, so that's looking at the entire system. Now, what would the mass be? Well, it would be the mass of Woodstock plus the mass of Snoopy, okay, plus, okay, the actual mass of the doghouse. Okay, so now we've included the entire system. And what's our language here? We're going to say it's the masses of the object also on the Earth, so it's an Earth mass system. Okay, so we're including Earth in the system. Now, what if we don't include, okay, the Earth in our conversation here? Let's just take a look at Snoopy in the doghouse, okay, and what interactions we have going on there. Now, of course, there is also, I should mention, there is an attraction for all these three, okay, to the Earth as well. So we could have also written a force of gravity from the doghouse, Snoopy, and Woodstock to the Earth as a Newton's third law pair. So please remember that the doghouse, Snoopy, and Earth also, or Woodstock, also attract the Earth. Okay, we're not getting that complicated in this video. Now, what about the interaction between Snoopy and the doghouse? Okay, let's do that. And I'll choose a different color so we don't get too confused here. Let's see what color might show up. I'll choose this color here. Okay, so we of course have a force going downwards, okay, and a force going upwards. Okay, so this force here is Snoopy, okay, to the doghouse. Okay, so let's call that now. It's a force of gravity, really, but it's a force of Snoopy, I'll say S, okay, acting on the doghouse. I'll label that as D this time. Okay, and then, what's going on here? Okay, this is actually the force, okay, of the doghouse, okay, pushing back then on Snoopy. So notice this time we've redefined our system. Our system only includes the doghouse and Snoopy and Woodstock. Okay, so how would we really calculate this? Of course, the force that Snoopy is pushing on the doghouse is equal to the mass of Snoopy plus Woodstock, and that's multiplied by 9.8. So it's the gravity force between Snoopy and Woodstock to the doghouse, and the doghouse just goes right back at you again. Now, please notice that the Earth is still there. The Earth is what's causing that force of gravity to happen. Okay, but we're just not paying attention to the Earth right now because we defined our system now just as a doghouse, Snoopy, and Woodstock. Now, of course, we can do one more definition of the system. We can look at Woodstock pushing on Snoopy and then Snoopy back again. Okay, so you can do a lot of Newton third law pairs, but in an AP test, just be careful of how the system is defined. Does it include Earth? Does it not include Earth when you're considering the calculation? But even though Earth is always there and the one causing the forces that actually are happening there. Okay, and that's it for our last video.